This Sim session is being brought to you by the Fractal Eternity. All right, today, 1-8 solving inequalities, 1-9 solving absolute value equations and inequalities. A linear inequality is the form ax plus by, ax plus b is less than c or greater than c, or less than or equal to c, or greater than or equal to c. All right, now if you have it down to x less than, greater than, less than, or equal to a constant, what you get is a graph which consists of a half line. So for example, x less than a, this graph is everything to the left of the point A and not including a, which I denote by an open circle. There's a notation called interval notation where it looks like this: negative infinity to a. This is the left limit, it goes off to infinity, and a is the right limit. X greater than a is everything to the right of and not equal to a. And that's denoted by this interval, round bracket a to positive infinity, round bracket. X less than or equal to a is like x less than a, only this time it includes a, which I denote here by a filled in circle and here by a square bracket. And x greater than or equal to a is like x greater than a, only it includes a with this filled in circle and the square bracket. These with the strict inequalities in the round brackets at both ends are called open half lines. This with the less than or equal or greater than or equal to signs with the filled in points and the square brackets are called closed half lines. So you solve a linear inequality by turning it into a half line using, well, basically the equivalent of transposition or the equality rules. If a is less than b, then you can add and subtract c on both sides. And same with greater than, less than, equal, or greater than or equal. If multiplication is a little complicated, however, as is division. Multiplying by a positive number keeps inequalities the same order. A less than b means AC is less than BC. A over C is less than B over C. But multiplying or dividing by a negative number reverses order. A less than B and C negative means that AC is greater than BC, and A over C is greater than B over C. So times a negative and divide by a negative reverses order. So it's sort of like transposition, only there's this complication of sign of multiplying and dividing. So for example, just a second. Good. Welcome aboard, Savannah Barton. All right, so 2x minus 7 is at least negative 29. Well, you add 7 to both sides. Get 2x is greater than or equal, same inequality sign, negative 29 plus 7. So 2x is at least negative 22. Divide both sides by 2, and since 2 is positive, that keeps the inequality sign the same. X greater than or equal to negative 20 over 2, 2 over 2. So x is at least negative 11. Its graph is this half line, including the negative pointing to the right of negative 11, which is included. Its interval is bracket negative 11 to positive infinity. Here we have t plus 1 minus 3t is at least t minus 20. Okay, here we'll subtract, let's see, we'll subtract 1 to move it to the right and subtract t to move it to the left. So you get on the left t minus 3t minus t greater than or equal, because adding and subtracting don't change this direction of the inequality, negative 20 minus 1. Okay. So this simplifies to negative 3t is greater than or equal to negative 21. Now, okay, to simplify this, we divide by a negative 3. That changes the greater than or equal sign to a less than or equal sign. So t is less than or equal to negative 21 over negative 3. So t is less than or equal to 7. It's this half line, including 7 and everything to the left of it. And this is denoted by the interval negative infinity to 7 square bracket. Here we have 4 less than or equal to 9/10 x plus 1. Okay, to get x, isolate x, first we subtract 1 from both sides. That keeps the inequality the same, less than or equal. So 4 minus 1 is less than or equal to 9/10 of x. So 3 is less than or equal to 9/10 of x. Multiply both sides by the reciprocal, 10/9, because that's a positive number that keeps the inequality sign in the same direction. 10/9 times 3 is less than or equal to x. That's 10/3 is less than or equal to x. That's everything, that's a half line, including 10/3 and everything to the right of it. Denoted square bracket, 10/3 to positive infinity, round bracket. You always put a round bracket near plus or minus infinity because the half line never reaches the infinite. Now you also have what are called compound inequalities, open intervals. So a less than x less than b means a is less than x and x is less than b. So x is between a and b. Or you can think of it as where two half lines intersect. This is called an open interval. There's also, instead of an and, we have an or, x less than a or b less than x. So you have two open half lines pointing in opposite directions. I call this a punctuated line, actually. So it's a union of half lines, whereas this with the and is an intersection of half lines. Now, okay, if you have an interval, a less than x less than b, it excludes both endpoints, and you have round bracket a to b round bracket. You have less than or equal to both ends, then it includes both ends, so it's square bracket a to b square bracket, called a closed interval. And you have these halfway examples. A less than x less than or equal to b, excludes x, includes b. So that's round bracket a to b square bracket. A less than or equal to x less than b, includes a, not b, so square bracket a to b round bracket. So these are half open intervals. So for example, 4 less than or equal to x plus 3 less than or equal to x. Subtract 3 from all three parts. 4 minus 3 less than or equal to x, less than or equal to 7 minus 3. Just a moment. So 1 less than or equal to x less than or equal to 4. So it's the closed interval from 1 to 4, including both endpoints. Here we have two half lines and pointing in opposite directions. 3x plus 2 less than 8, or 2x minus 3 is less than 11. Okay, for this one, we subtract 2 from both sides. 3x is less than 8 minus 2, so 3x is less than 6. And divided by positive number 3 keeps the inequality the same, and you get x less than 2. Or here, 2x minus 3 is greater than 11. Add 3 to both sides. 2x is greater than 11 plus 3. 2x is greater than 14. Divide both sides by 2. 2 is positive, so this keeps this inequality the same, and you get x is greater than 7. So x is less than 2, or x is greater than 7. So here's a union of half lines. Minus infinity to 2, union 7 to infinity. Now, here they get a little tricky. Nonlinear inequalities, some of which can be solved by what they call sign graphs. For example, x plus 2 times x minus 3 is greater than 0. This x plus 2 goes from negative to positive at negative 2. This x minus 3 goes from negative to positive at, I should be 3. Just a second. This is 8, 6 at 3. I have to change this. Let me count this. Okay, so here's what we do, a sign graph. Looks like this. We draw a line, put x here, put the sign of x plus 2 times x minus 3 here. When x is negative 2, x plus 2 times x minus 3 is 0. When x is 3, x plus 2 times x minus 3 is 0. Above 3, both of these factors are positive, and positive times positive is positive. When it goes through 3, the second factor, x minus 3, becomes negative. So you have plus times minus, which is minus. Below negative 2, both of these factors are negative. Negative times negative is positive. So this expression goes from positive to 0 to negative to 0 to positive. Want to know where it's bigger than 0? Well, it is here for x less than negative 2. It's not here at negative 2. It's not here where it's negative. It's not here where it's 0. It is here above 3 where it's positive. So the solution graph is everything to the left of negative 2 exclusive, as well as everything to the right of 3 exclusive. So that's the graph. The inequality is x less than 2 or 3 less than x. And the interval is negative infinity to negative 2 union 3 to infinity. Here's another one. X plus 2 times x minus 1 times x minus 3 is less than or equal to 0. Well, okay. Here's the sign graph. We draw x here and the sign of this thing here, x plus 2, x minus 1, x plus 3 here. At negative 2, when x is negative 2 or 1 or 3, the expression is 0. When x is above 3, all these three factors are positive. Plus times plus times plus is plus. When between 1 and 3, you get a plus times a minus, which is minus. Below 1 and 3 and above -2, this expression is plus times minus, which is plus. And below -2, all three of these factors are negative. Negative times negative times negative is negative. So negative to 0 to plus to 0 to negative to 0 to plus. When is it less than or equal to 0? That's the question. Well, it is here, below -2. It is here at -2. It isn't here between -2 and 1. It is here at 1. It is here between 1 and 3. It is here at 3. And isn't here above 3. So the graph consists of everything up to -2 inclusive, and also 1 to 3 inclusive. This is the graph, as you can see from these check marks. So x is less than 2, or x is between 1 and 3. Minus is infinity to the -2 union 1 to 3. The square brackets here. Now we have one where x minus 2 squared times x minus 3 times x plus 1 is less than 0. Note the second power. What happens is that the graph has what's called a double root. It starts positive, then flips, then just touches 0 for a brief second, and goes back to positive. So we get what's called a double root. All right, so let's start off. So we do a sine graph. X here, sine of this thing here. Okay, at -1, 2, and 3, the expression is 0. Above 3, it's plus squared times plus is plus. When it flips below, goes below 3, between 2 and 3, get plus squared times plus, which is minus. Then something a little weird happens. When it goes below 2, between -1 and 2, instead of a plus squared, we have a minus squared times plus. But minus squared is plus, the result is minus. So here it goes from minus through 0 to minus. And below -1, these are all negative. Negative squared times negative is plus. So when is it less than or equal to 0? Not here where it's positive. Oh dear. Oh, I'm sorry, this should be a less than. This is page, my apologies, 8. This should be a less than. I'll change that in the canvas. Okay, so not here at -1. Yes, here between -1 and 2. Not here at 2, where it briefly is, where it's for a brief moment, an instant is 0. Yes, here between 2 and 3. Not here at 3, yet not here above 3. So the graph is from -1 to 2 and from 2 to 3, all these excluded. -1 less than x less than 2, or 2 less than x less than 3. -1 round bracket, -1 to 2 round bracket, union round bracket, 2 to 3 round bracket. Now here we have an expression with divisions, which will still can solve by a sine graph, but it'll have infinities as well as zeros and pluses and minuses. X minus 3 over x plus 1 is at least 0. Well, okay, as a sine, here we have a sine graph. Here we'll put the sine of x minus 3 times x plus 1. At x equals -1, we're dividing by 0 and we get an infinity. At x equals 3, you get a 0. Above 3, it's plus over plus, which is plus. Below 3, but above -1, it's minus over plus, which is minus. At -1, it's infinity. And below -1, it's negative over negative, which is plus. And when is it greater than or equal to 0? Yes, here, below -1. Not here at -1, where it's infinity. Not here between -1 and 3, where it's negative. Yes, here at 3, where it's 0. And yes, here above 3, where it's positive. So the graph looks like this half line excluding -1, and this half line to the right of and including positive 3. So x is less than -1, or 3 is less than or equal to x. It's denoted by this union of intervals, minus infinity to -1 round bracket, union square bracket, 3 to infinity. Now here we have an annoyance. 4 over x is less than or equal to x. Well, is we don't have a comparison with 0 here. We do that. We solve that by transposing the x. 4 over x minus x is less than or equal to 0. This is 4 minus x squared over x is less than or equal to 0. And then this 4 minus x squared, we can factor to 2 minus x times 2 plus x. This is the difference of squares, 2 squared minus x squared. Difference times sum. So 2 minus x times 2 plus x over x is less than or equal to 0. Okay, sine graph. Here we go. At -2 and 2, it's 0. At 0, we're dividing by 0, we get infinity. Here we go. Above 2, this is negative times plus over plus, which is negative. Going through 2, it's plus times plus over plus, which is plus. Going through 0, between -2 and 0, it's going to be plus times plus over minus, which is minus. And below -2, it's plus times minus over minus, which is plus. Where is it less than or equal to 0? Not here where it's positive. Yes, here where it's 0. Yes, here where it's negative. No, here where it's infinite. No, here where it's positive. Yes, here where it's 0. And yes, here where it's negative. So going by the check marks, the graph is -2 inclusive to 0 excluded, union 2 included to infinity. So -2 to 0, union 2 to infinity. So -2 less than or equal to x, less than 0, or 2 less than or equal to x. This solves this. Here we have another comparison of fractions. X plus 2 over x plus 3 minus x minus 1 over x minus 2. Again, the best way to do this is to subtract this from both sides. I mean, if it were an equation, we could transpose and so on, but that involves multiplying, and that can mess things up. So here we go, especially the sign. X plus 2 over x minus 3 minus x minus 1 over x minus 2. Bit of algebra, a bit more algebra, a bit more algebra. Here we go. Minus 2x minus 1 over x plus 3 times x minus 2 is less than 0. Okay, in the sign graph. The expression is infinite when x is -3. It's infinite when x is 2, and it's 0 when x is -1/2. Above 2, it's minus over plus times plus, which is minus. Between -1/2 and 2, it'll be minus over plus times minus, which is plus. Between -3 and -1/2, it's plus over plus times minus, which is minus. And below -3, it's plus over minus times minus, which is plus. When is it less than 0? Well, not less than 3, not at -3 where it's infinite. Yes, between -3 and -1/2. Yes, at -1/2 where it equals 0. No, between -1/2 and 2 where it's positive. No at 2 where it's infinite. Yes, above 2 where it's positive. So this is the graph. It's the interval from excluding -3 to including a -1/2, giving the interval excluding 2 off to infinity. -3 less than x less than or equal to -1/2, or 2 less than x. These are the solutions.